In this lesson, we're going to be seeing how we can add fractions together. Now, in order to do this, we will need to remember what the different parts of a fraction mean. And so on the top here, we've got the numerator. That tells us how many pieces we actually have, whereas the denominator on the bottom, that tells us how many pieces we'd need to make up one whole. We'll also need to understand how we find equivalent fractions. If I start with 3/5 and I was to multiply the top and the bottom by 3 by the same number, I get an equivalent fraction. Remember, the idea is with an equivalent fraction, they have exactly the same value even though the numbers they're using are different. So if somebody was to give you a pizza and you cut it into 5 slices in total and you ate 3 of those slices, or if you cut it into 15 slices in total and you ate 9 of those slices, you would eat exactly the same amount of pizza either way, because both these fractions have exactly the same value. Now, simplifying is when we divide the fraction, the top and the bottom, by the same number and end up with an equivalent fraction with smaller numbers than the first one had. And that's why it's simplifying, because maths is usually simpler when the numbers get smaller. Remember, these two fractions have exactly the same value. This one just uses smaller numbers to express that value. And if you're wondering how I came up with 10, I simply asked myself, what's the highest number that goes into 20 and also 30? Whenever you're simplifying, you should always have a quick look at your answer to see, is there anything else that goes into the two numbers? Because if I did not pick the highest number to start with, then let's say I picked 5 here, I would end up with 4/6, and that could be simplified further. When you're satisfied there is nothing else that goes into 2 and 3, you know you've got simplest form. Finding the lowest common multiple is also going to be necessary in this lesson. So to get the lowest common multiple of 4 and 7, what we're asking is, what is the lowest number that 4 and 7 both go into? Usually a number that's bigger than 4 and 7, but it could actually be one of the numbers itself, though not in this time, because 4 does not go into 7. And so if I wanted to, I could list a lot of multiples of 4 there. Remember, this is just like the 4 times tables, and I could do the same for 7, and I could work out, well, 28 is the lowest one that is on both times tables. But you want to be able to do it without having to list them, and if possible without having to use your times tables, being able to do it in your head, just thinking what's the lowest number that's on the 4 times tables and the 7 times tables. And finally, we are going to have to change improper fractions into mixed numbers. And so if I've got my improper fraction here, remember it's improper because the numerator is larger than the denominator, and that means it has a value of more than a whole. So what I do is I do 10 divided by 3, just the numerator divided by the denominator. That tells you how many wholes there are, so there'll be 3 wholes, and the remainder is just expressed as this fraction on top here. So this is how many wholes there were, and this is how many remaining. Alright, let's get into adding fractions with these two here. We're going to add 2/7 to 4/7. And so let's begin by drawing 2/7. I've got my shape and I've cut it into 7 sections and I've shaded in 2 of them. And again with 4/7, same thing, but this time I shaded in 4 of them. And so how many sections do I have altogether? I'm just adding. And so I've got 1, 2, 3, 4, 5, 6 sections. And note that 7 still make up a whole. I don't add 7 plus 7 to get 14. I'm not doubling how many sections make up a whole. It's still the same. It's still only 7. So in the end, I'd end up with 6 of them shaded in out of 7. And so there's 2 key things here. Firstly is when the denominators are the same, the numerators can just be added. And most importantly is you do not add the denominators together. They will stay the same because the numerator represents how many pieces we've got. They're the things we're adding. The denominator represents how many pieces make up a whole. That's not changing. No matter how many pieces I add together, still the same amount will make up each whole. Now, what about if I started with 3/8 plus 1/4 though? That's going to make things a bit harder, because here's the diagram for 3/8. And here's the one for 1/4. The main thing you need to notice is that this piece is much bigger than these pieces there. So I can't add them together. I can't just say there's 4 pieces because they're not all of the same size. And so what I'm going to need to do is make the pieces here the same size as the ones there. And that means I need to cut this into the same amount of sections as that one there. Then the pieces will all be the same size. So since this one's got 4 and this one's got 8, I'm just going to have to double the number of sections there. So there we go. I've now cut it into 8 sections. Notice now 2 of them are shaded instead of just 1. And so I've got 3 8s there, and I've got 2 8s here. So that's really what I'm adding together. And then once again, now the denominators are the same. I can just add the numerators because there's 3 pieces there and there's 2 pieces there. So altogether, I'm going to be having in shaded 5 pieces out of the 8. And so that's 5 8ths. And so if the denominators are different, they will need to be made the same before you can add. Whatever you do, don't add these fractions and say it's 4 over 12. You'll drive your maths teacher absolutely nuts. Now, in order to get these denominators the same, we need to find the lowest common denominator. And so if I've got 8 and 6 here, what I'm looking for is what's the lowest number that 8 and 6 both go into. In other words, it's the lowest common multiple of 8 and 6. So lowest common denominator and lowest common multiple in this case are exactly the same thing. So what's the lowest thing 8 and 6 both go into? And that would be 24. 8 goes into 24 3 times. 6 goes into it 4 times. There's nothing more, there's nothing lower that they both go into. So that's what I've got to use. And so I turn 8 into 24 by timesing by 3. And I must remember to do it to the top as well, or I wouldn't have an equivalent fraction. Remember, I'm not trying to change the value of this fraction. I'm just trying to change the numbers that it uses so that it's got a 24 on the bottom. And here I've got to turn 6 into 24. So I times by 4 on the top and the bottom because 4 sixes are 24, and now I can write down my new fractions. So I do all that timesing I've just written down there, and I write down my new fractions. Now the denominators are the same, so I could just go 3 plus 4 is 7. After that, it's a very easy question. So once you find the lowest common denominator, things get a lot easier. Now, if we happen to have whole numbers when we're adding, they're actually quite easy to deal with. Some people would suggest just changing these into mixed numbers to start with, but that's not necessary when you're adding. All you need to do is just add the whole numbers separately. And so that means I've got 4 wholes there, because that's 1 plus 3. Now I can add the fractions normally. So 3 over 5 plus 4 over 5. If the denominators weren't the same, I would make them the same first, just like normal. In this case they are though, so 3 plus 4 is 7. That means it's 7 over 5. Now here's the only little extra bit you're going to have to do. See how this is 4 and 7 over 5? This 7 over 5 part is an improper fraction. We don't want that. So what we're going to do is we are going to change this into a mixed number. Now you might say all of this is already a mixed number, which in case you pretty much correct, but we're going to change just this fraction part into a mixed number like so. So there's the 4, and this becomes 1 and 2/5. So I've got the 4 wholes I already had, plus the extra whole that I get when I change that to a mixed number, and I've got the 2/5. So that becomes 5 and 2/5. Now finally, every time you get an answer, you're going to need to try to simplify it if you can. So let's say I had this question, 3 over 8 plus 1 over 8. Denominators are already the same, so I just add the numerators. That means I end up with 4 over 8. I have to try and simplify this. Now if nothing went into 4 and 8, then that's my final answer. But since something goes into 4 and 8, which is 4, I need to divide it by that number. So I divide them both by 4, and I end up with 1 over 2. Remember, that has exactly the same value as 4 over 8, but the numbers are smaller, so it's our simplest form answer, and that's what we always want to get to. And so just have a look at 1 and 2. Does anything go into 1 and 2 apart from 1? Because we don't bother dividing by 1, nothing changes then. And there's not, of course. So that means I've now reached my final answer for that one in simplest form. Let's have a look through some examples now. We're going to start by working out 1 over 12 plus a quarter. So let's write it down, and we're going to try and find our lowest common denominator. Now just a little tip here, if the lowest number goes directly into the highest number, then it's much easier because you're only going to have to change this fraction here. If it doesn't go directly in the higher number, you're going to have to change them both into a bigger number. But in this case, 4 goes directly into 12. So we'd have to times it by 3 to get to 12. So we times top and bottom by 3, and on the next line down, we write down our entire new fractions. Well, this one's not new, but we have to write it down again anyway. And this one's our new fraction based on our timesing. So now the denominators are the same. Let's add the numerators together. 1 plus 3 is 4, so that's 4 over 12. And we can't move on yet because this is not in simplest form. We have to check, does anything go into 4 and 12? Yes, it does. 4 goes into 4 and 12. So divide them both by 4, and you end up with 1 over 3. Just a quick note before getting to the next one, these green numbers here, the timeses and divides, you don't need to show them. I'm just putting it there to show what my thinking is. You can do that if you want to. If you find it makes it easier to remember, that's fine, but you don't have to show those. Eventually, hopefully, you won't need to. So, looking at the second example here, so let's write it out. 7 over 10 plus 8 over 15, and we're going to have to find that common denominator. Unfortunately, 10 does not go into 15 this time, so what's a bigger number that 10 and 15 both go into? It's a little bit harder because 15, we don't really know our 15 times tables, but it's 30. 10 goes into 33 times, so let's times it by 3, and 15 can be made into 30 by timesing by 2. So now underneath that, let's write down our new fractions after we've done all that timesing. The denominator is now the same, beautiful. 21 plus 16 is 37, so we end up with 37 over 30, which we can then make into a mixed number. How many times does 30 go into 37? It's only once, and there's 7 remainder, so it becomes 1 and 7 over 30. And now let's take a look at adding one that's got whole numbers in it. So let's write out the fractions to start with, the whole question, and we've got to get the denominators the same. 4 does go into 8 here, so that's helpful. That means I only have to times this side by 2. Remember, we do not change the whole numbers at all. They don't affect the common denominator, nothing like that. You're just dealing with the fraction parts at the moment. So times the top and the bottom of just the fraction by 2, and write down our new ones. So the whole numbers are the same. This fraction has now changed, the numbers, not the value, but the numbers, and this one stayed the same. So now I can add my whole numbers together, that's 3, and because the denominators are the same, I can add my numerators together, which gets 11. And so I get 3 and 11 over 8. Now finally this one, unfortunately I can't leave it like that because the numerator is higher than the denominator, so I'm going to have to do 11 divided by 8, which is 1, and 3 remainder, and so I know that that would be 1 and 3/8. Here's the 3 wholes that I already have over there, so when I add them together I end up with 4 and 3/8. It's not necessary to write this section down. That's fine, you can just do that in your head. In fact, you're encouraged to be able to go from that step to that step just in your head. Okay, let's give it a go with some practice questions. Remember to pause the video. And there's the solutions to those ones. Just remember those green timeses there and the divides, you don't need to worry about writing those down, but if you did, that's also fine. So in this first one here, I started by writing out the fraction, and I had to find the lowest common denominator. So what's the lowest thing that 5 and 4 both go into? And it's 20. It's the lowest thing I could certainly think of there. And so how do I turn 5 into 20? I times it by 4, which means I have to times the top by 4 as well. And how do I turn 4 into 20? I times by 5, means I have to times the top by 5 as well. So after I did all that timesing, I ended up with these 2 fractions here. Remember, these have the same value as the 2 fractions up the top, but they're just using different numbers. And the important thing being, we've now changed it so the denominators are the same. Because once we've done that, we can now add those numerators together, and we get 27. Remember, we don't change the denominator when we do it. We're not changing how many pieces make up a whole, so we don't change the denominator. And so then all I had to do is change that into a mixed number, because of course that's an improper fraction. So 20 goes into 27 one time with the 7 remainder. In the second one, I wrote down the question, and then I realized, and I was happy to see, that 3 goes directly into 6. So I just multiplied this fraction here by 2 on top and bottom, because that'll turn the 3 into a 6. And when the denominators were the same, I added the whole numbers together. That's why that's 8. And I just added the numerators together, and I kept the denominator the same. So that's why that's 3 over 6. And I was happy to see as well that the numerator was not bigger than the denominator in this case. That's always helpful. But I did notice something goes into 3 and 6. And so I had to divide the top and the bottom both by 3 to end up with 8.5. Here is a couple more practice questions if you need to have another go. Remember to pause the video. And there's our solutions to those ones with all the working that needs to be shown, except of course there's green sections. You don't need to show those if you don't want to. And that is the end of this lesson.